laws of indices then, there they are, and it's worth trying to remember them. Certainly having them written down somewhere so you can quickly refer to them. If we just look at some examples of them. The first one, for example, a to the m times a to the n. The important thing to remember about these is that the a, which is the base, has got to be the same. So in other words, if I have something like 4 to the power 3 multiplied by 4 to the power 5, for example, then that's the same as 4 to the power 5 plus 3, which is 8. So you add the powers. If you multiply two things where the base is the same, you add the powers. Similarly for number 2, law 2, so long as the base is the same, if you divide, you subtract the powers, and that's what that's saying there. And you need to remember those. The other ones sort of follow on, really, from them. So laws 3, 4, 5, and 6 all arrive from 1 and 2. And you can show how that's done. And I've done that in previous sessions, and there may well be video clips showing it. If we look at number 3, for example, a to the m, so something like x cubed and then squared, you multiply the powers together, so we get x to the power 6. And then divide, and then we get some interesting ones come along. For example, something like the 4th root of x cubed can be written as x to the 3 over 4. And we've talked about this sort of thing before. Okay? The root, in this case the 4th root, the only thing you're likely to forget is which number goes underneath, which one goes on top. Roots tend to go under the ground, so roots go underneath in the fraction. And you might well remember that to be able to differentiate something like this, you need to write it in that form to be able to differentiate it. So that's one example of where we would use this fraction power. And because fractions can occur in the powers, then if you think about it, we can start to think about getting problems where we have to combine laws 1 and 4, for example, to work out what x to the 2/3 multiplied by x to the 1/2 is. And then we have to combine the powers. Gives us x to the 2/3 plus 1/2. So then we have to remember how to add fractions. Common denominator would be 6, so we turn them both into 6. X to the 4/6 plus 3/6 is 7/6. So it would be x to the 7/6. I wouldn't write it as a mixed number. We tend to leave the power as an improper fraction, 7/6, so we can write it in root form. It could be the 6th root of x to the 7. So we start to have to combine these laws. And then we look at numbers 5 and 6. This number 5 is an important rule. Again, when we're talking about differentiating the inverse, it's something that I'm often talking about. If I want to differentiate an inverse, I write it as a negative power, and then I can differentiate it. And the last one is just telling us that anything to the power 0 is 1. So those are the laws of indices. What we need to be able to do then is to use these laws of indices in the first instance in algebra to simplify things. So in the textbook, around about page 40, 41, you'll see some examples asking you to simplify terms like this. And all you do is use the laws of indices to do it. I've got the same base here and here, a and a, so I can combine those. I've got effectively a cubed times a to the power 1, which is a to the power 3 plus 1, which is a to the power 4. So this becomes a to the power 4. These, a squared times b cubed gives me b to the power 5. 2 plus 3 is 5. And c to the power 1 multiplied by c to the power 5 is c to the power 6. So we can use the first law of indices to help us simplify things, remembering that, of course, if c and is on its own, it means to the power 1. We might need to simplify by adding, as I've implied already, adding and subtracting fractions. So what would we do to simplify this one? We would have a to the power a half plus a sixth, so we'd have to find the common denominator, b to the power 2 plus a half, and c to the power minus 2 plus 1. So we would just combine the powers like that. And then you could carry on and simplify that further by adding the fractions together. Okay. Something like this. The way to approach something like this is to remember that if I've got a fraction like 2 plus 3 over 6, I can split this fraction into 2 over 6 plus 3 over 6. I can write each of the numbers in the numerator over the denominator. So to simplify something like this, the first step would be to write this as x squared y cubed over xy plus xy squared over xy. I split the fraction into its two parts and then use the laws of indices. Because we're dividing these x's, it will turn out to be x to the power 2 minus 1, because division we subtract the powers. Y's 3 minus 1 plus, again, x to the power 1 minus 1, which is just 0. In other words, x to the power 0, which is just 1. And then y to the 2 minus 1. So to be able to simplify expressions where I've got a numerator which involves additions and subtractions, like this one in other words, I split it and write it as each term over the denominator, and then I can simplify it. So those sorts of things are the things we need to do, and then we can use these algebraically to simplify things. So have a look at the exercise that follows on in the textbook, exercise 21 on page 42, and we'll just try some of those for a few minutes.